But the test of this, the real test of this is there any way to tell, some other way to tell who's correct? And that sort of brings us back to the argument that Colin made, which is, look, the reason why you know it's moving is if you throw a ball up, if you let it go outside the car, it goes backwards. So if we're actually moving, we should see that. So Galileo's argument is, well, let's take some sort of something that we think is moving and try that same experiment. And see, is there anything in the behavior of the ball that is different than when I'm standing still? So when I'm standing still relative to the Earth, we just see it go up and come back down. But what happens if I throw it up and it moves? Let's try that out. Now, I have to say, first of all, that it's a tradition in physics lectures and chemistry lectures, things like that, to have some really dangerous pyrotechnic demonstration. I do not have that for you, all right? But I have to say that I have not been on a skateboard in 20 years, and then I was not able to ride a skateboard very well together. So to try to go on a skateboard and throw the ball at the same time is like death-defying. So I want you guys to appreciate how dangerous this moment is about to be. So now I'm going to go on a moving flame here, and I'm going to toss this ball up. I'm going to see what happens. Does the ball go back? Is it just, as soon as I toss it up, it's back to the Earth, or does something else happen? All right.
No, here.
Try one more time. All right. Now I'm on. Okay, so what's going on there? So from my perspective, I need to balance on this, which is the difficult part. But once this is actually moving, I just throw this up and down, I don't really need to do anything special. The motion I'm doing there is pretty much the same. So let's again look at this from different perspectives. So Einstein talks about, I think, a reference frame is one thing to use. But the other thing Einstein talks about is coordinate system. So the idea is that each reference frame, has its own coordinate system. So you are all best relative to each other, you got your coordinate system, and I have a different coordinate system. And we think about what does the motion of the ball look like. So from your perspective, I threw the ball, and it came down. So as I'm going along, I throw it up over here, goes up, goes back down. That was the path the ball followed. What does it look like from my perspective? Well, from my perspective, I just threw it up, and it came back down again. There's no difference from my perspective, other than the fact that I have to balance on this, between just standing here and throwing the ball up and down. Right? And there is if I'm actually moving, throwing the ball up and down. To me, they seem the same. Right? As long as I'm with rest relative to myself, which I always am. So this is the point that one of the points that Einstein makes in your reading, which is what path does the ball follow? So in one coordinate system, your coordinate system, your reference frame, it follows this sort of parabolic arcing path. In my coordinate system, it just follows a straight line, up and down. In the bird's coordinate system, it goes the other way. In the bird's coordinate system, it's going faster than I am. So I release it here, and then I catch it back here. But the bird, these things are moving that way. So the ball actually goes like that, the bird. So then we have a sort of tricky problem, which is something that we thought before had a sort of universal answer to it, now becomes a little bit relevant, which is where does the ball start and stop? Now, I'm not talking about, so one thing is relative to your particular position. So everybody would agree, let's see, that if I throw the ball up here, for some people over there, I threw the ball up to your right. For people over there, I threw the ball up to your left. And then I caught it over here. That's to some people's right and some people's left. But wherever you're sitting, you're all in the same reference frame, which means you're not moving relative to each other. And so you can all agree on the following statement, that I threw the ball to the left of what caught the ball when I'm on the skateboard. So whatever your starting point is, if you're there, as long as you're not moving, right, relative to each other, everybody would say the ball was caught to the right of where it was going. I, on the other hand, would not say that. For me, the ball goes up in my hand, comes down in my hand. The ball is thrown from the same point at which it is caught. Right? So I would not say the ball, those two events, the throwing the ball up and catching the ball, took place at a different location. They took place at the same location, right where my hand is. From the bird's point of view, the ball is thrown to the right of where it's caught. Ball is thrown here, and over there. So all of a sudden, things which seemed before to be sort of more absolute become a bit relative. There's no such thing as some absolute position. They're saying, oh, the ball definitely moved from left to right, or definitely moved from right to left. It all depends on which reference frame you're in. And Einstein's point is, if you ask the question, what path does a ball take, there is no answer to that question. Right? I can say the ball took this path relative to some particular reference frame, relative to somebody who made a certain velocity relative to the ball, for example. But there is no absolute answer saying the ball took a curved path, like this, or the ball took a straight line path. There is no correct answer to that question.